Hello everyone, welcome for this session. And now we are starting with the topic 3, which is eigenvalues and eigenvectors. It is very vast topic. We will start with the basic things first of all, and then we'll try to understand how to find out the vector corresponding to the eigenvalue for the given matrix. So let us proceed further. Basically, first we need to understand what are the eigenvalues. So before we proceed further, let me explain you one system which we are calling as the linear transformation. Suppose we are having, earlier we have discussed with m equations and n variables, correct? Now we are going to consider n equations and n variables. Now this particular system is represented in terms of this pattern: a11 x1 plus a12 x2 plus and so on till xn and is equal to y1. Means by means of all of these xi's, we are going to get y1 value along with the coefficients. Similarly, a21 x1 plus a22 x2 plus and so on till xn is equal to y2 and so on. an1 x1 plus an2 x2 plus and so on is equal to yn. Now you can observe here, this system is little different than the system we discussed in linear algebraic equations. Correct? Now this system talks about certain transformations from xi's to yi's by means of this particular matrix. Now once again, this particular system we are going to abbreviate in terms of matrix notation, and that matrix notation is this one. So all coefficients we are clubbing together in this matrix A, which is called as a matrix of transformation. This is your matrix X and this is your matrix capital Y. So we are representing our this system in terms of y equal to ax, where x will get transformed to y by means of this A. That way we speak about this equation. Correct? Okay. Now next term is y equal to lambda of x. Now y, which is equal to basically ax, that means this matrix of transformation is transforming x to y. Now instead of using matrix here, can we use certain lambda so that x will get transformed to y by means of scalar instead of a matrix? Now, if this is your equation 1, if this is your equation 2, using these two equations where left hand sides are similar, right hand sides we can equate and we'll get the equation ax is equal to lambda x. Correct? Here, lambda and x satisfying this equation is called as a eigenvalue and eigenvector of the matrix A respectively. So, for this matrix A, different lambda values we can identify that transforms capital X to Y. So corresponding capital X for corresponding lambda is called as an eigenvector, and that lambda is termed as the eigenvalue. So our interest is to find out the lambda values and X values. Now how to find it out? Let us try to understand. So from equation 1 and 2, we could get this particular equality. So let us take this lambda x to the left hand side. So ax minus lambda times I into x is equal to 0. Now here, this is a matrix equation which is true to its operation. Correct? Why? Because left hand side is the product of matrices, right hand side is the product of identity matrix and this x and multiplied by scalar. Now when we are taking this term to left hand side, it again represents a subtraction of two different matrices of similar order. So that subtraction is compatible, possible. right? So A minus lambda times I is equal into X is equal to 0. Now X being a column vector we are separating, and now in bracket we are having A minus lambda times I multiplied by X is equal to 0. Now carefully look into this particular round bracket. Now round bracket we can simplify in this way. A11 minus lambda, because I is the identity matrix, so all diagonal entries of this particular lambda times I is nothing but all diagonal elements as lambda and the rest of elements as 0. So A11 minus lambda, rest of elements as it is.